All right, welcome to this new series of videos where we are going to demonstrate step by step how to build a system for creating custom crown forms for making hats. And when I say system, I mean we're not going to just create a single custom crown form. We're actually creating a system that allows any individual to create a custom style of crown form based on existing styles, and then use that, 3D print that, and use that for making their own hats. Now you might be saying to yourself, well, I don't make hats, so why would this be interesting to me? Well, this would actually apply to any type of manufacturing that uses existing forms. And so a shoe last is another good example. And here we have, this is a sneaker that was made off of this last. So this is another good example. If you had existing styles of different types of shoes, you could then create your own custom shoe in your own style. All right, now let's go back to shoes for a second. If we were going to design a custom shoe, it would not just be a custom style, but it would need to be customized to the person's exact foot shape as well. All right, and so in this more simplified system, we're ignoring shape, but eventually we want to include both style and the exact foot shape. And I'm going to do a little bit of a sidebar here because this is where we get into our next series of videos, which is going to be around a codec avatar. All right, so you might ask, what is a codec avatar? And when I edit this, I'm gonna put an image here. On the left side of the image, we're going to have a 3D model of an actual person. It comes from an actual scan of a person. On the right-hand side, we're going to have a synthetic version of that model that is based on all of the measurements of that person. Now, this gives us a couple of advantages because, number one, we don't have to scan the person. We can just take some normal measurements the way you would if you were tailoring some clothes. And number two, it sort of obviates privacy concerns because we're not storing any personalized information about the person. The most important part about this is that if we design our thing, our shoe, our hat, whatever, if we design it to the actual model of the person, then when it comes time to customize, what we can do is we can design our style around a generic foot shape and then substitute in the custom shape of the actual person from the avatar, which will then parametrically change our style to match that exact person's foot. So in that case, we get both the custom style and the customization of the foot size and shape. And I think that is incredibly powerful. All right, that part about the codec avatar is going to be in a second set of videos, but everything that we're doing here when we talk about customizing these using 3D models, we're laying sort of the base for all of the technology that we're going to need to get to that codec avatar. So essentially everything we're doing here is going to translate, but this is just a much simpler, easier way to get into the details of the technique. Okay, so that was the why of what we're doing. Now let's get into the actual the details of what it is we're going to do, and we're going to start by walking through how we actually get a 3D mesh model of our various styles. I should add here too, also just some insight as to how this system is going to work. The reason we need 3D mesh models is that what we're going to do, or the way the system works, is we'll have extremes of different dimensions of shape, and these will both be mesh models. And in our computer system, we will essentially be able to use sliders to blend these two shapes together to get some combination of these two different shapes. And it won't be just these two, it'll be all of the existing shapes that we have. And hopefully, and what we're looking for is basically finding some extremes of these shapes, basically essentially the outer edges of like all of the different styles that are available. All right, so the first step is going to be, I'm going to walk you through how we do a 3D scan of an existing vintage form, and then how we clean that up into a model that we can then 3D print and use in our system. All right, this is the vintage crown form that we're going to scan. And you'll notice that it's got a lot of discoloration. We're not too concerned about that. It's also made of rubber, whereas traditionally a lot of the older ones are going to be made out of wood. This one's made out of rubber. But it does look like it's in pretty good shape. It's hard to tell, but the discoloration doesn't matter. But there's no big chunks missing or anything like that. Like we have a few like little pores here, and there's a little bit of crustiness. But once we scan this thing and then do a little bit of a cleanup, none of that will be noticeable at all. It'll be like equivalent smoothness to one of these other ones. All right, now one thing to note, and the question might be like, why this particular one? Okay, now you'll notice that this particular form has almost like more of a square shape, or like a coffin shape, right? And that's actually what we're trying to capture in our shapes. So we have some like the extremes of different dimensions. Like this one's more of a triangle. This one's sort of a teardrop. This one has a distinct sort of diamond shape to it. So having one that's more square is sort of the opposite of this diamond dimension. So, and the more extreme we get our dimensions, the more variability we'll have in our ability to create a custom shape. So this one will be a really interesting one to add into the mix. And you can see it's even wider out here. It doesn't really come to a point. It comes more to a flat. All right, so this is going to allow the customization, or whoever's customizing their design, to add that extra dimension to the shape that they want. All right, one other thing you might notice is that this vintage form is not the same size as these other ones. So it's a different size. Now, that isn't going to matter for us in this process, because what we're going to do is we're going to normalize all of the models to be the same size. And in this case, the size of a crown form is based on its circumference. So we will be scaling this model up to match the circumference of these other ones. And then when you create your custom version, you will then scale that aggregate down or up to the correct size of whoever your target customer is. All right, I might clean this up just a little bit, just get rid of some of these little crusty bits. But the first step to this that we're going to get into is we're going to do the laser scanning. The first thing we're going to do is we're going to put fiducial markers, and we're going to put those all over this form. And those fiducials are essentially registration points for when we do our laser scanning. Okay, this is our 3D scanner setup. We have our handheld scanner here. We have a computer that runs the software. We have this carousel that already has some fiducial marks on it. And here's the the crown form that we're going to be scanning today. All right, now sometimes I refer to this as a laser scanner, but what it is a photogrammetric scanner that uses lasers to create structured light. So what does that mean? What does the structured light mean? Well, essentially there's a laser here, or a set of laser lines coming out from the middle, and we have two cameras, one coming this way, one coming this way, and they're aimed at a certain point in space, and the software compares that structured light, the line created by the laser. It looks at it from two different angles in order to figure out the relative depth of those points in space. All right, it uses that relative distance from the laser to then create an absolute depth in space by registering it to a constellation of markers. So the first thing we're going to do, as I mentioned earlier, is we're going to put those markers onto the form that we're going to scan. Okay, these are the markers. They're retroreflective dots, and I would consider these to be expendable because you're going to need a lot more than you think, because you're basically going to try to cover like maybe every 1 to 2 inches across this form. And also the adhesive, it's a very light adhesive, so and that's intentional because you don't want it to damage the thing that you're sticking it to. So we're gonna have to put a lot of these on here, and you may want to buy an extra pack of these because essentially once you're done scanning this, you may end up having to throw them away. They don't really reuse very easily. All right, now this form is sort of symmetrical, so I like to basically put the same pattern on both sides so I get the same quality of scan. And I usually would start in the back, and we'll put a line right here down the back, and then we'll start working our way across one side. Okay, so we'll start getting our fiducials off of this sheet of paper here. And the spacing we're going to want is probably something like this. That's maybe an inch and a quarter. All right, and then we're just going to start working our way around here, and maybe like making little triangles as we go. We want to have like a little bit of variability so that we have a unique constellation of fiducials as we work our way across. All right, I'm going to continue doing this, and when I get to a relevant point, I'll stop and point something out to you. Okay, so we filled up this area roughly every maybe inch and a half, inch and a quarter. Okay, now we're getting to the area where we have this, where the fedora, your fingers go on the crown of this fedora. We're getting this to the area where this crease starts to happen. Now, one thing about these fiducials is that after the scan is done, we're going to have to clean it up by removing the fiducial, because the fiducial actually shows up in the scan, but it shows up as a slightly raised little disc in the scan, which we don't want. Now, we can take that part out, but the way the software fixes it, it tries to fill that up. And in order to get a nice smooth shape, we want to avoid putting the fiducial on these little ridges and creases. We want to put it on areas that are basically as flat as possible. So we would not want to put them on these curves here or on these creases, but we would want to put them inside here where it's relatively flat, here where it's flat on the top of the crown, not in these creases, not on the edge, but maybe put some on the flat part of this ridge. Okay, so try to avoid any curved space, because we're relying on the software to sort of fill that, and it's going to be easier if it fills it when it's flat, not curved. Okay. All right, so I filled it up all the way to the front. I stopped in the middle here, and then we're going to duplicate it on this side. But now for this little pinch part, you can kind of see that what we have here is we have sort of a flat, well, obviously there's a little bit of a crease here that makes sort of a bean shape. But within this bean shape, there's a little bit of a flat at the top, and then a curve, and then another flat area here. So it looks like what we want to do is we want to avoid the middle where there's a little bit of curvature, and we're going to put it on the flat. So I'm going to put one, like maybe one here, probably one there, and one there to get good coverage of that inside shape. Okay, so like that. Try to get as flat as possible. And then right there, and then do one more here. Okay. All right, that looks pretty good. I might add one more right here so we get a good part of that edge. All right, we want to catch that corner. Where it's still flat, but it's going into these creases. Okay, so now we've got one half done. What we're going to try to do is we're going to try to mirror this pattern. Doesn't have to be perfect, but it'll give us a similar quality if we mirror this pattern onto this side. Okay, and I'll see you when we get to that. All right, coming on the other side. Okay, now I've got both sides, and now we're going to do the top of the crown. And again, I'm going to try and treat it as if it's symmetric. So we're going to put one in the front and the middle. One back here in the middle. We're trying to keep a little bit off of that crease where it curves up. And then we'll probably do, looks like we could get away with 4 up here in the top, middle. And then we're going to want to capture more on the edges here. All right, I might put maybe 2 more here, but then we're also going to maybe put, there's enough of a flat edge here. We'll do a few up here, one here, and then a few over here. We might be able to get one on the end here. All right, I'm going to do that, and I'll see you at the end. Okay, so we've finished putting our little retroreflective fiducial markers on here, and you can see I've added like 3 on each side on this ridge to sort of complete that. All right, so now we're ready to actually do our scan. And you can see here in the software, we got the RevoScan 5 Metro X software that comes with the device. We're going to click on New Project. We're going to use the default project name, which has a date code in it. And right now it automatically is starting the scanner. So if I pick up the scanner, I can see that it's creating these crossed laser lines, and that's a setting that we're using here under scan mode. We're using cross lines, and we're using marker tracking in this setup. And you can see in the screen here, it's showing the crossed lines right now on the map along with the fiducials, and it's also showing our scan quality here. And we want to keep this in the green, so if I move it too close, it goes orange. If I move it too far away, I'm good, but I'm not great. And when I get to this far away, I'm orange again. So I want to be in the zone where it says excellent, which is looks like about a foot away from where I'm scanning. Okay. All right, now before we do the scan, we're actually going to put it on this carousel. And one important thing is I like to put it on a little bit of a stand, like so. Let's see, we want this right up there. You want to make sure that that's steady. Okay, now the importance of this is that we want a clean edge here at the base. We want to be able to go all the way down to the base. Now, if this were actually sitting on the floor of this carousel, it would be hard to separate the floor from the edge. But by giving that little bit of lift, I now create a gap that's going to be easy. When we edit this, we can just like cut that whole section out. It's going to make it much easier, and the software will automatically fill the bottom, and the bottom's just going to be flat for now. So having that little spacer to lift it up off of the base is going to make it much easier to get a nice clean edge here at the bottom of the hat form. Okay, now we're ready to scan, and I'm going to turn this carousel on so it automatically rotates. I'm going to get my position. I want to be in the green, and once I'm in the green, I'm going to hit, and you also need to have enough fiducials visual or in the camera sight. Once we have that, we're going to hit start, which will actually start our scan. And you can see that it's actually starting to build up the shape of the crown as it's rotating. And again, I like the cross lines scan mode for this because it gives us some of the best results. Okay, we're going to continue to do this. You're going to have to hold this for like maybe a few minutes. And as it goes around, you'll see that we're starting to we did one complete turn. We're going to want to get the entire crown, which means you're going to have to sometimes move this up to get the top and the back. And similarly, you're going to have to move it down to get the final edge. Again, you're going to have to do this for maybe 3 or 4 minutes until you have a complete scan of everything, okay? Okay, once we're mostly green, looks like we've scanned pretty much the whole hat. Some of these areas can be cleaned up afterwards. Okay, once we've gotten to where we want, we go over here, we hit complete. And that will stop the scan, and it will start processing the scan. And we can turn off our carousel here. All right, so this is our raw scan right here, raw scan. Now is when we start to get into the cleaning up and processing of this hat form scan. Okay, so here's our raw scan. Now there is a one-click button here for processing this, but what we're going to do is instead, I'm going to show you each one individually, step by step, so you have a better understanding of what's going on. All right, so we're going to start with fusion in this upper left-hand corner. We're going to do fast fusion, and we're going to try a point distance of 0.15, which is recommended. And then we're going to do a remove marker here. Now the thing we're going to do also is we're going to set the hole radius. The marker is 5 millimeters. We're going to set the hole radius to 7 millimeters because what that will do is that'll give us a more of a crisp, clean line. If we do it at the exact size of the fiducial itself, there's going to be a little bit of a raised edge that's going to sort of mess up our future cleaning of this mesh. All right, so 7 millimeters to remove the hole, and we're going to use the recommended fusion distance there. Okay, and we hit apply. It's going to take a while for this to start working. Okay, so that process finished up, and you can see that it has removed the fiducials and left some like fairly large holes. It's kind of like a Swiss cheese. That's okay for now. In fact, the fact that it's you can tell that it's really flat around that hole, that's a good thing. We don't want to see any raised edges around there. The other thing that it did for us is it automatically took the things that were small below here and eliminated those. All right, so now we have a nice clean edge around the bottom of the base, which in a future step we're going to simply close that off. Okay. All right, so that was the fusion. Now we're going to go to isolation. This basically isolates small areas for removal, and so we're going to do a detect, and anything that's less than 15% will be detected. Okay, so we have a lot of little small pieces that are disconnected here. Everything that's turned red is disconnected from the main mesh. So we're going to eliminate those because those will be separate meshes. We don't want that. All right. So that was the isolation step. Okay. We don't need, we're going to do overlap detection. So basically this is if two meshes, if we recorded two separate things that are very close together, but it thinks that are separate. So like if there's an error in the scan, in the registration of the scan, we want to detect that. And we're going to use the recommended distance of 0.3 millimeters. And again, if it detects anything, it should show up as being red. So it looks like I got a little piece in there. There's a few pieces that are overlapped, so we're going to apply that to eliminate those. All right. Okay, smoothing. Okay, so we applied the smoothing at a strength of 10 and 10 times, and then below here there's a description of what it's doing. It looks okay. We did lose a little bit of detail, but we're actually going to be losing even more of that. We don't need it to be that rough. When we get into the CAD step, we're going to be smoothing it out a lot more than what you're seeing here. So that losing that little bit of texture doesn't matter a whole lot. Okay, now we're going to get to simplify. This basically reduces the mesh size essentially, which makes it easier for compute. So let's try a uniform. Let's try the default here, 40%, and see what we get here. With a smaller mesh, it's gonna make the computation faster for the future steps. Okay. All right, that didn't seem to do much, but it simplified the mesh there. All right, we're going to want a high quality mesh. The quality here, this setting gives us a grid size of about 0.5 millimeter. I think that's going to be fine. We're going to want to turn the hole filling on. 30% will get most of these holes, but not the bottom. And again, we want high quality mesh. Let's try that grid size. I think that should be fine. 0.5 millimeter. Okay, so that took a few minutes for that to process, but you can see that it filled all the holes where the fiducials were, and you can kind of see a little shadow here where the fiducials were, where it's like a little bit smoother and looks like maybe a little bit flatter. So again, that's the exact reason why we would not want to put one of these like on a curved section, right? Because it's filling it automatically, algorithmically, and we want it's going to try to do it as flat as possible, and so we want to be putting those on flat surfaces. All right, so it filled all of the holes where the fiducials were and every other hole smaller than that, but we still kept the bottom open. Okay, there is one last step that we need to do with this mesh, because we do still have this hole at the base, and we do want to have that filled so that this mesh is interpreted as being a solid when we import it into CAD, which allows us to perform operations on it as a solid. So we're going to go under Mesh Edit, we're going to go to Fill Holes. We're going to Detect. So every hole it detected is green. We only have this one, and we'll select that. It turns it red. And click Apply. And let it process. All right, and now we have a flat here. Now you can see that it's not a completely planar flat, but what we're going to do later, the operation we're going to do and bring into CAD, is we're going to take a nice clean slice, a single plane across the bottom, and that will clean that up, clean it up nicely. All right, now we're going to do the export over here. Export, we want to export the mesh model. We're going to use the default, the PLY, and we will do it into the downloads folder. Click OK, and we're going to jump into a different software to show how we check and confirm that we got that mesh export. This is a program called MeshLab, and you basically just go over here to import mesh and navigate to where you save this mesh. Now you can see this looks the same here, and it's closed on the bottom. We can also check if we want to look at the triangle version of this. We can see each individual triangle that's used to make up that mesh. And you also notice here that the areas where the fiducials were, because there's less texture, there's a simplified mesh in those areas, which is fine. All right, so this looks good, and we're going to take this into our CAD as the next step. And at this point, I'll probably end this video, and then we'll pick it up in a second video in the series, and we'll be starting that second video by importing this mesh into Rhino and then start adding features to that. All right, stay tuned for the next one, and thank you for watching.